All right, problem 8.8, millimeters, grams, and seconds. Part origin location is indicated in red, so the back mid. Part is symmetric, so pretty much from there to there. Sketch is fully defined, lines, circles, center lines, arcs, rectangles, sketch fillets, lofts, extrude boss, extrude cut, and the reference geometry for the plane, loft between a square sketch and a planar face. So what they're saying is that the region that's going to be generated at this line is we can offset to this point. Realistically, I think what would make this a loft is this is still pretty well centered. Um, this geometry could be done with a cut extrude and cut extrude triangles. Not really seeing, even shifting it, I think I could probably get it all in one or two features. But loft is convenient, so we will go with it. So opening up our sketch. I think in an exam setting, the loft is handy if there were geometry that just screamed, do it as a loft. But I think from a certainty that it's going to work, I would probably stay with the cut extrude. So, all right, let's go into the to the top plane. We're going to do a center line for 76, and that will get us started. And then this has the has a step, so we'll go that way, and down, and then coming back that way to that way, and we'll make that coincident. All right, close enough. We can window pick everything, mirror. Again, we could do the diametral on those. Oops. Let's see. Let's just Control Z that. They did the 22 on the inside, and then 5. And because it's symmetric, we should be able to get all of those. And then last will be the 44. All right, so that looks pretty good. For our step then, we have 55 to the end. So what it's not giving me is the calculation to the radius. All right, so that being the case, kind of need that that number. So let's go ahead and extrude it, and we'll generate that next sketch, and I'll come back to the geometry. So our overall is 38, and we'll open up that sketch. All right, we need a, let's just go 3-point, and we'll connect the two dots, and that's going to have a radius of 25. From the end point to the base is 24. To get that in position, then, nope, we need the arc and the line. So that's going to give us the tangency to that edge. All right, let's go 15, just so we have that geometry through. And then I would like to have a driven dimension. All right, so there's actually a bit going on there. If we generated this sketch first, we could tie that that line to the geometry. So, is it going to be worthwhile to stay with that or to come back and do it later? All right. Well, since I like to make things complicated, and I'm not really seeing that geometry doing much in the way of a benefit, Let's bring that back to there. And then we're going to extrude cut and through all. All right, when we go back to the top, now I'm just going to be able to do rectangles. And could probably drive it to our geometry. So we had the 5, so that actually works out pretty good. Want both of those to be equal, and then that can cut extrude through all as well. And probably needed to go the other way. Okay. Yep. Oh, at least on that one I needed to go the other way. All right, so let's get rid of the coincident and bring that up. Yeah, so that one got a coincident, that one did not. All right, let's just pick one and go collinear or... All right, so got rid of the minus signs. All right, that looks good. All right, let's get the extruded cut through all. There we go, that looks better. And yeah, that is a partial. All right, so our plane then is out an additional 25. So let's just go into the reference geometry plane, first reference, and the dimension then goes to 25. And we can open up a sketch. And let's just go with let's just do a corner rectangle. We're going to center this with a couple of center lines. So if I go that way with that one, and that way with that one, I should be able to select the midpoint and go make midpoint. And then our distance, 21 and 21. Okay, and then we can hide the plane. And what we're looking for is that face and that sketch. We can go directly into the lofted base. All right, so it doesn't work because it's twisted, but if I bring it back, it's a little less twisted, and if I bring it to the other corner, that is actually what we want. All right, and then the other item is a through hole. So I would like to see sketch 4 as a show because it's already got the center in it. When we put the hole through, okay, just making sure that it picked up that inference. 11 millimeters, features, extrude cut, and we'll let it go through all again, and then I can hide sketch 4. All right, so let's save that. We are at P8-8. And our volume then is shifted on me again. Is the 8888 8889.7. So let's see if I can, no, it's still trying to do that. Maybe my zoom, all right, 88897. Evaluate mass properties, 88897.3. All right, I think we're good on that one. So let's go ahead and take a look at the 8.9. All right, again, they're saying do a loft, millimeters, grams, and seconds. Part origin is located at the base. We will, part is symmetric. All sketches are fully defined. Lines, circles, center lines, lofts, extrude boss, extrude cut, reference geometry or planes. The cap is lofted. All right, so again, I could see doing that as a revolve. I don't know that the the difference. It's probably probably we're going to say no major difference. So front plane sketch. So let's get the loft out of the way. It has a initial diameter of 20. What we'll want to be careful of is making sure that this is going the way that we plan. So front plane, hold down the control button, drag it off, and we'll go 8 millimeters. And then open up a sketch and pick the origin again, jump right into the dimension, and we are at 15. And we can hide the plane. Oh, didn't want to hide it that much. We'll get back into our features, lofted, and because there's only the two, we're not going to mess with that those grips. Leave them as they are. Let's see, there's a hole from the side. So let's go with the, what do we have, a diameter of 14. And let's see if we just go rectangles. All right, so probably could have just done the center line and mirrored them, but we'll go ahead and put those in. Actually, those can go that way. Select midpoint. We'll make the midpoint horizontal. Select midpoint horizontal in between the two. All right, so let's get some dimensions in. We said 14 for the OD, 6 on the width, and between is 8. Oh, and since I did not do a center line and make it symmetrical, I have to add the last dimension. And then just to make it fully defined, we'll go that way. All right, features, extrude. Let's grab the region, and that is 15 millimeters. And we'll set it that way. All right, so then the top plane, we go into the sketch. We look for the inference, but chances are it didn't apply. So we're going to select Control Select the origin and the center, make those vertical. Our dimensions then go 6 from the end. And diameter of 5. All right, and then this is going to become an extrude cut through all both and accept. Let's go ahead and save it. 8-9. And the volume on this one is 3476. All right, so evaluate mass properties, pretty close, 3463. So 4 cubic millimeters. Okay, it's around somewhere. We'll call this one good and move on. So let's take a look at the last one. All right, millimeters, grams, and seconds. Part origin is indicated in red. I don't see any indications in red, so put it where you want it. But realistically, probably at that point, the origin in this case is really only going to come into play if we were doing a center of mass. So part is symmetric about what we're going to consider the front plane. Sketch is fully defined. All fillets on the path are equal. So they gave us a radius of 12, and that looks like it's going to the interior. Lines, center lines, circles, sweeps, and planes. All right, so let's go ahead and open up our metric template. We'll go into the front plane and we're going to start drawing. Just keep in mind that if it's easier for you to draw a portion, then draw as much as what makes sense and get it fully defined. And then it's less likely that those inferences that continually pop up are going to, oh, that was fun. Now, hopefully that wasn't a pause in my video again. All right, so let's just do that as an example. We have 48. And our radius was 12. And we'll go ahead and make those two equal. And then we have an angle of 55. Okay. Let's see, the overall. Now that was given to a virtual, all right, so we have dimensions to a virtual sharp. Those are always interesting because we can try to calculate it, but it's always better just to select the two lines. When you hit the point, it's going to create that virtual sharp for you. All right, so tangent, we'll come back. I don't know that we need a virtual sharp here. Let's just hit L on the keyboard to get back into the line. I'll use a continuous arc, so I'm using all of the arcs on this one. And we'll go vertical, continuous arc, back some distance, and we'll just pick up the tangency. All right, so now we can do the 145 overall. Well, that ought to be interesting when it comes back the other way. When it loses its mind because we drug something too far, we're just going to drag it back, keep adding dimensions, process of elimination. We're going to get all of those items in there. All right, so now we're going to utilize that virtual sharp. Notice it has an icon, the little star, and we're going to go to 75. Its distance is 38. And again with the virtual sharp, let's do it afterwards. All right, so if we didn't know about the virtual sharp, okay, so, it's going to put those extensions. If I didn't know about that, I could always draw the point and make it an intersection or coincident to the first one, coincident to the second one. Both of those would work. All right, and by virtue of that point, we're still going to get to a fully defined. So that one has 115. Okay, that makes sense. Just checking that I'm looking at that correctly. When you do the linear, stay close to the line, stay close because as soon as you get out far enough, it's going to shift to horizontal and vertical orientations for the smart dimension. All right, we got it all in there. So fully defined, don't see anything too crazy. Let's go into the top plane. And we have a rectangle that is 6 by 25. So we'll get those in there. All right, and from the very beginning of this level, we've been saying as long as this does not self-intersect, then the geometry should be good. So just watch if you pre-select that when you do the SWEP, sometimes it tries to wrap it around that one, which is a little strange, but this is being an open profile. It can't really, but there are times where it does do some strange selections. All right, 46575. Evaluate mass properties. 46 574.8. Yeah, that's pretty good. So let's make sure to save this. 8-10. Oh, I guess we'll put the problem in there. And yeah, I think we're good.